95, we're going to talk about Chapter 7 today. Chapter 7, we move away from the graphing and the linear equations for a little bit here, and we get into exponents. This will then lead us into polynomials in Chapter 8, and then factoring in Chapter 9 and 10. So you may remember those things from other classes, you might not. Either way is okay. So it will be much easier if you have your notes in front of you. They are on Lumen, Chapter 7. There are blank ones and completed ones, and even if you don't print them out but you just have maybe a split screen, it will help to be able to follow along with this. Okay, so if we have an exponential expression like this, x to the n, you can see that at the top of your paper. This is called the base, and this n is called the exponent or the power. So we may see something like 3 to the 4th. We could say 3 to the 4th power, or 4 is the exponent there. What this means is that we're going to multiply x by itself n times, whatever n is. Okay. So, for example, 3 to the 4th does not mean 3 times 4. It does not mean 12. It means 3 times itself 4 times. These get big very fast. Okay, so 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Okay, and actually in the news right now, you may have heard talk about exponential growth and exponential graphs. So when you see the graphs of the projections of what could have happened with the coronavirus cases, and it goes up very fast, that's exponential growth, because you can see I have 3, and then 3 times 3 is 9, and then 9 times 3 is 27, 27 times 3 is 81. If I had another factor of 3 there, it'd be 243. They just get big very fast, so that's kind of the basis of that. So we're seeing this with exponents right now in everyday life. All right, so whatever this is, that's how many times this number or that variable gets multiplied by itself. So we are going to go through some rules of how we work with exponents and how we combine them. We'll do some practice on doing that and working with them. We'll talk about scientific notation, and then at the end of the chapter we'll talk about roots or radicals, like square roots, cube roots, that kind of thing. Okay, so with these rules, there are 5 rules we're going to go through. And I have an example of each on there, and then on the notes you see kind of one that you can try. So we'll go over it together, but hopefully you can pause the video and then try it on your own and then start the video again in each case there. I'm also going to show you kind of what's happening behind the scenes of those rules. So there's a rule, when we do this, we add these, but I don't want you to just memorize it. I want you to understand what's happening so that if you forget the rule, you can recreate it. Okay, so let's go ahead and get started. So number 1 is called the product rule. And as you can see, the product rule says that when we multiply expressions with like bases, so we multiply expressions with like bases, we add the exponents. Okay, so like bases, meaning having the same base here, whether it's a number or a variable. So my example there is x to the 4th times x squared. Okay, so we can just jump to the rule, and you see that there in my example. But let's first think about what's really happening behind the scenes. So x to the 4th means x is being multiplied by itself 4 times. X to the 2nd means x is being multiplied by itself 2 times. And then these two things are being multiplied. Well, since it's the same base, I'm multiplying x over and over. Here's my x to the 4th, here's my x squared, but now we can kind of look at it all as one expression. If you look at that, x is being multiplied by itself 6 times now. So this does follow that rule. X to the 4th times x to the 2nd, same base, we add the exponents. But we can also see here why. So do I expect you to write this out every time? No. Especially not if we have x to the 37th times x to the 50th, right? We don't want to write that out. But this is what's happening behind the scenes. So if you ever get to this point and you can't remember what to do with the exponents, you can make yourself a little example like this and find out what it is. Okay. So the you try it is x to the fifth times x to the third. Okay, so go ahead and pause the video for a second and you can try that. If it helps you to write it out, you can. Okay, so x to the fifth times x to the third. We're going to add those exponents. It's going to be x to the eighth. Again, if you're thinking about what's happening behind the scenes, this means there are 5 x's multiplied. This means there are 3 x's multiplied. That means altogether there are going to be 8 x's multiplied together. Okay, just a couple points about this. If I had x to the second times y to the third, I can't combine that at all, right? There's nothing else I can do with that because it's not the same base being multiplied over and over. So this just has to stay like that. And the other thing I wanted to point out also, let me see if I can get a marker that writes a little better here. The other thing I wanted to point out is that this also works if your base is a number. So let's say I have 3 squared times 3 to the fifth. Again, if I think about what's happening behind the scenes, I have 3 times 3, and then 5 3's being multiplied here. I can see that there are 7 3's being multiplied. Note that the base doesn't change. Just like here, x and x, there's still an x there. This is not a 9, right? It's 3 to the second, 3 to the fifth is 3 to the seventh. So that works also with numbers as the bases. Okay, so go ahead. As I'm erasing here, go ahead and look at the second part, the quotient rule. Quotient rule says kind of the opposite, that when we divide like bases, I should say, expressions with like bases, we subtract the exponents. So let's, again, kind of see what's happening behind the scenes here. So the example there is x to the fifth over x to the third. So what does this mean? This means x multiplied by itself 5 times. And this means x multiplied by itself 3 times. Okay. Well, what happens whenever we have something on the top of a fraction and on the bottom of a fraction that's a factor? I can cancel it out. So I can cancel out that x and that x, and that x and that x, and that x and that x. And what I have left is these 2 that did not get canceled out. That is x to the second power. Going back, we can see that's kind of why this rule is what it is. I take the exponents and I subtract them. I always subtract top minus bottom. This is again saying how many x's are multiplied by themselves here, how many are here. Since I'm canceling some of these out, the difference here is what's left. Again, also would work with bases that are numbers. So 4 to the fifth over 4 to the first is going to be 4 to the fourth. Okay, you can picture that. 4 times 4 times 4 times 4 times 4. 1 on the bottom, it cancels out. I have 4 left. Again, only works with like bases. Okay, the example on here for you to try is x to the 8th over x to the second. Think about the rule. If you want to write it out, you can. We should have gotten x to the 6th. Okay, again, do you need to write this part out every time? No. But if you get to this point and you forgot what to do, then you can subtract those, or you can, write them out to remind yourself that you're subtracting. Okay, the third rule is the 0 power rule. And this says, excuse me, this says that anything raised to the 0 power, or having an exponent of 0, that means, raised to the 0 power is going to equal 1. Okay, it does not mean that the exponent equals 1, it means the entire expression is going to equal 1. So, for example, if I have x to the 4th to the 0 power, this is being, sorry, my cat's trying to get out of the room. This is being raised to the 0 power. That equals 1. Okay. Now let's look at this for a second. Let's look at two different things. One of these is on your notes sheet and one is not. And they look really similar, right? 3 times x to the 4th to the 0, or 3x to the 4th all in the parentheses raised to the 0. Here's what we have to remember about exponents. Exponents are not very strong, so they only affect whatever's right next to them. So this 0 exponent only goes with whatever it's right next to, which in this case is parentheses. So it's going to go with everything in those parentheses. So this thing right here is being raised to the 0 power. So this is 1, but the 3 is not raised to the 0 power. So it's 3 times 1, which is going to equal 3. Okay, because this part right here is being the part that's raised to the 0 power that becomes 1. Let's look at this one. Now, this exponent is with those parentheses, but everything is in parentheses. So all of this is being raised to the 0 power. So again, this whole thing is 1. So just watch what exactly is being raised to the 0 power. Alright, I'm going to stop this video. I'll be back with the next video with the next 2 rules, and then we'll do some examples.